All right, welcome back. We're almost there, everybody. Let's scroll on down to lesson 14. We are now on Foundry DAO/governance. And of course, all the code that we're going to be working with is in this GitHub repo. So if you want to follow along, feel free to go here. Now, there's a ton of conceptual stuff to go over before we get into this. But basically, we're going to learn everything about what a DAO is, what they're for, and how to use them. And as we're going along and as we're learning about DAOs, I want you to take some time to read these two articles. They're both from Vitalik, and they address a lot of the main concerns with DAOs. One of them are that DAOs are not corporations, where decentralization in an autonomous organization matters. And this article came out in response to a lot of people having really hard coordinating DAOs, because since they're decentralized autonomous organizations, and it can be difficult sometimes to coordinate with so many people and so many heads. So this article is really interesting where DAOs work really well and sometimes where they don't. And this one is one of my favorite articles about plutocracy. Plutocracy is government by the wealthy. This is something that obviously sounds bad and something we want to avoid in this new system that we're creating. If we default to typical ERC20 based governance, we're going to run into a lot of issues outlined in this post. If that doesn't make sense to you right now, don't worry, it will. And we'll come back to this in a little bit. But first, let's learn about DAOs, what DAOs look like and how they actually work, especially as developers. So I made some videos about this in the past. Let's go ahead and watch those, and we'll come back. Now, before we learn how to code a DAO, we should learn what a DAO is. And again, I've already made a video that I put a lot of work into. So we're going to watch what a DAO is from a high level first. Then we're going to learn how to code a DAO. Now, DAOs, or decentralized autonomous organizations, is a bit of an overloaded term, but it typically describes any group that is governed by a transparent set of rules found on a blockchain or smart contract. And I say overloaded because some people say Bitcoin is DAO because the miners could choose whether or not to upgrade their software. Other people think that DAOs must use transparent smart contracts which have the rules ingrained right into them. And then other people think DAO is just a buzzword, so they just slap the name really onto any organization so that they can get some clout. And this makes for sad Patrick. And this is not to be confused with the DAO, which was an implementation of a DAO back in 2016, which set the record for the largest hack at that time. So there's a lot of different ways to think about it, and the DAO term is used in a lot of different ways. But in essence, imagine if all of the users of Google were given voting power into what Google should do next. And the rules of the voting was immutable, transparent, and decentralized. This solves an age-old problem of trust, centrality, and transparency, and giving the power to the users of different protocols and applications instead of everything happening behind closed doors. And this voting piece is a cornerstone of how these operate, this decentralized governance, if you will. And it can be summarized by company or organization operated exclusively through code. And to really understand all this, we're going to look under the hood of the protocol that's setting the precedent for all other DAOs. In Compound. Then, once we look at Compound, we'll understand what goes into building one of these and all the trade-offs, all the different architectural choices mean for your group. And then, in my next video, I'm going to have a full code-along tutorial for developers looking to build one of these themselves. But be absolutely sure to watch the rest of this video because it's going to give you all the architectural fundamentals so you can make intelligent decisions when you get to that section. And be sure that you and your DAO friends smash the like and subscribe button so we can keep giving you the best engineer first content on the planet when it comes to smart contracts. Let's get into it. So here we have the Compound protocol. It's a borrowing and lending application that allows users to borrow and lend their assets. And everything about this application is built in smart contracts. Now, oftentimes they're going to want to do a lot of new things. Maybe they want to add a new token to allow borrowing and lending. Maybe they're going to want to change some of the APY parameters. Maybe they're going to want to block certain coins. There's a lot of different things that they might want to do. So that's where we're going to go ahead to governance. This is where you can find a user interface for a list of all the proposals and all the different ballots that came to be. So here's a list of some of the governance proposals that this protocol has actually been making to improve. And let's look at one of these proposals that's currently actually in process. So if we click on the proposal, we can actually see everything about this proposal, who voted for, who voted against, and the proposal history here. Now, the first thing to one of these proposals is somebody has to actually create the proposal in a proposed transaction. And we can actually see that proposed transaction right here. If we click on this, and we scroll down, we can actually see the exact parameters they used to make this proposal. Let's go ahead and decode the input data, and we can see this is exactly what this proposal looks like. The way that they're typically divided is they have a list of addresses and a list of functions to call on those addresses, and then obviously the parameters to pass those addresses. So this proposal is saying, hey, I would like to call support market on this address, set reserve factor on this address. Here are the parameters we're going to pass. They're obviously encoded with bytes. And then here's the description string of what this is doing and why we're actually doing this. The reason we have to do this proposal governance process is that these contracts likely have access controls where only the owner of these contracts can actually call these two functions. And the owner of these two contracts is likely going to be this governance DAO. And values to 0 just means that we're not going to send any ETH along with these transactions. Once a proposal has been created, after a short delay, it becomes active. And this is when people can actually start voting on them. This delay between a proposal and an active vote can be changed or modified depending on your DAO. Then people have some time to start voting on them. And if it passes, which this one overwhelmingly did, it reaches succeeded. If we click on this transaction again, and we go to the compound governance contract, and we scroll down to contract, write as proxy, we can actually see the exact function that the people called to vote, namely cast by vote, cast vote by signature, and cast vote with reason. We'll talk a little bit about the exact differences between these in our next video, but these are the functions that they're actually calling. And if you go to the compound app and we go over to vote, this is a user interface you can actually vote through to make it easier if you're not as tech savvy. So you can vote right through this app.compound.finance, or you can just send the transaction yourself. Once all those votes happen, it reaches this queued stage. Now, what does queued mean? Well, before a proposal actually becomes active, there's a minimum delay between a proposal passing and a proposal being executed. So somebody has to call this queued function, and it only can be called if a vote passes, and it says, okay, that proposal ID has been queued, and we're going to execute it soon. Now, if we go to a different proposal, like this one, for example, we can see it has been executed. We can see somebody called this executed function, and they executed proposal 82. So this is going to be a full example of the life cycle of a proposal going through this process. Now, there are a couple that even failed. A whole bunch of people voted against this. And if you scroll down, you can see it was created, it was active, and the majority of people voted against. So that's where it stops. Now, oftentimes, just putting one of these proposals through isn't enough to really garner some votes for it. You generally want a forum or some type of discussion place to talk about these proposals and why you like them or don't like them. Oftentimes, a discourse is one of the main places that people are going to argue for why something is good or why something is bad, so people can vote on these changes. And again, Snapshot might be one of these tools that you use to figure out if your community even wants something before it even goes to vote. You could join one of these, and with your tokens, actually vote on things without them being executed, just to get the sentiment. Or, like I said before, you could build your protocol in a way that Snapshot actually helps you with the voting process. All right, now you've seen the protocol that has been influencing all the other DAOs on how to vote. Now you know. Now that we know what a DAO looks like, let's talk about the architecture and tools that go into building one of these, and additionally, the trade-offs that they have. And the first thing to talk about here is going to be the voting mechanism. Now, voting in decentralized governance is critical to these DAOs because sometimes they do need to update and change to keep with the times. Not all protocols need to have a DAO, but those that do need to have a DAO need a way for participants to engage. This is one of the most important questions to ask and to tell your communities. How do I participate? How do I engage in this DAO? How do I help make decisions? And you'll find this is a bit of a tricky problem to solve. Now, an easy approach to this problem is going to be using an ERC20 or an NFT token as voting power, similar to what we saw with Compound. Use the comp token to vote for different proposals. Seems simple enough, right? Boom, problem solved, hooray! Now, this actually might be the right approach for certain DAOs, but it also runs the risk of actually being less fair, because when you tokenize the voting power, you're essentially auctioning off this voting power to whoever's got the deepest pockets. Whoever has the most money gets to pick the changes. So if it's only the rich people who get to vote, then it's highly likely that all the changes in the protocol are going to benefit the rich, which doesn't really seem like that great of an improvement over our current world. NFTs are interesting because they have this non-fungible component, but yet even they still run into this issue. Additionally, if you buy a whole bunch of votes, you make a bad decision and then sell all your votes, you as an individual don't really get punished. You just punish the group as a whole. But you being malicious, you can get away with pretty scot-free. Now again, this voting mechanism is going to be correct for some groups, but for other groups, maybe not. It really just depends on what your DAO and community setup is going to look like. Now, the next one we're going to talk about is skin in the game. Now, Vitalik has actually written a lot about this, and I highly recommend you read his article, link in the description to see that. The skin in the game method means that whenever you make a decision, your vote is recorded. And if that decision leads to a bad outcome, your tokens are axed. So you get punished for making evil or bad decisions for your DAO and your protocol. I like this mentality because even if you buy a ton of tokens and decide to be evil with it, you can be held accountable for your bad decisions. Now, the hardest part about this though is going to be, how do we decide as a community what is a bad outcome? How do we actually punish these people? And that's easy, because the answer is, I'm not sure. Now, the third method of this voting mechanism is probably one of the most interesting ones, but also the hardest ones to implement. And this is proof of personhood or participation. Imagine that all users of the Compound protocol were given a single vote simply because they used the protocol. And even if they had 1,000 wallets that use the protocol, one human being means one vote. This would be amazing and a far more fair implementation where votes couldn't actually just be bought. The issue, however, comes in something known as Sybil resistance. How can we be sure that it's one vote equals one participant and not one participant pretending to be thousands of different people so they get more votes? This method hasn't really been solved yet, but I'm willing to bet some very clever engineer will do some amazing Chainlink integration, because proof of personhood is basically just off-chain data that can be delivered on-chain, and that's exactly where Chainlink shines. Now, as you can see, all of these methods, and even more that you probably think of, aren't that far-fetched. And we actually see these exact same methods happening in the real world. Proof of personhood or proof of participation might just be the exact same as kind of the regular government voting that we see every day. In the United States, at least, one person gets to vote for one president. You can't go around making a whole bunch of fake people and voting for president. But in companies, the ERC-20 voting standard kind of applies. The more shares of a company you have, maybe the more voting power you have in that company. So we can draw parallels between the real world and how voting and governance is going to work in our smart contracts. And in fact, you should draw parallels and look for inspiration from the Web 2 space. Now, when it comes to implementation of the voting, I put them into two categories: on-chain voting and off-chain voting. On-chain voting is exactly what we saw with Compound. There's a smart contract, on-chain, you're a voter, you call some function called vote with your MetaMask, your Ledger, or whatever, send a transaction, and boom, you voted. Congrats, you can wear your little sticker now. Call that function and you send a transaction. You send a transaction. What do transactions use that are kind of annoying and kind of costly? Oh, that's right, gas. Imagine you have 10,000 people in your community and it costs $100 to vote per person. You're now costing your community $1 million anytime you want to change anything. This is obviously insane and not very sustainable for your community. The pro here is that the architecture is really easy. Everything's going to be transparent. Everything's going to be on chain, and that's really good. But yes, the con is that you're going to break the bank account for a lot of people, potentially. Now, there are a lot of variations of this to help solve some of these problems, especially the gas problem. One of the ones that I'm incredibly excited for is this one called Governor C, where they use some random sampling to do some quadratic voting to help reduce costs while increasing Sybil resistance. If you want to learn more about that one too, be sure to read about it in the description. So on-chain voting is the simplest one here, but let's talk about off-chain voting.
How could you possibly vote off-chain in a decentralized context?
Relax. You can vote off-chain and still have it be 100% decentralized. You can actually sign a transaction and sign a vote without actually sending to a blockchain, and therefore without actually spending any gas. Instead, what you can do is send that signed transaction to a decentralized database like IPFS, count up all the votes in IPFS, and then when time comes, deliver the result of that data through something like an oracle like Chainlink to the blockchain, all in a single transaction. Alternatively, what you could do is you could replay all these signed transactions in a single transaction to save gas. This can reduce the voting cost by up to 99%. Right now, this is an implementation, and one of the most popular ways to do this is through Snapshot. And I'm just dying for someone to make a Chainlink integration because it's going to be so much safer, more secure, and better, and blah, blah, blah. Dying for it. This is your call to action. Go build this thing. This off-chain voting mechanism obviously saves a ton of gas to the community. and can be a more efficient way to store these transactions anyways. However, it needs to be implemented very carefully. If you run your entire DAO through a centralized oracle, you are essentially reintroducing a centralized intermediary and ruining the decentrality of your application. So don't do that. And if you made it to this point of the video, give yourself a little pat on the back. You're doing fantastic. Learning is fantastic. Like I said, I have a video coming out after this one that's going to show you end to end how to build one of these from scratch. But let's learn about some of the tools that you can use help get you up to speed quicker. Now, there are a number of no-code solutions that can go into building one of these DAOs. DAOstack, Aragon. Just kidding, this is Aragon. Colony and DAO House are all alternatives that can actually help you with the ops side of running a DAO and building a DAO. However, if you want more granular control and you don't want to have to pay any of the fees associated with these protocols, you might want to do it from scratch. Now let's talk about some of the more codey solutions that you can use. Snapshot is one of the most popular tools out there for both getting the sentiment of a DAO and actually performing that execution. Users can vote through this protocol with their actual tokens. Those transactions get stored in IPFS, but none of it actually gets executed unless the DAO chooses to. So this can be a great way to get the feel for what your DAO wants to do. And optionally, you can send the transactions and execute the votes as well. I highly recommend checking out Zodiac, which is a suite of DAO-based tools for you to implement into your DAOs as well. Tally is another one of these UIs that allow people to see and actually vote and interact with these smart contracts through a user interface. For those of you who don't know about Gnosis Safe, you absolutely should. Gnosis Safe is a multi-sig wallet. And the reason that I put this on the list, even though it adds kind of this centrality component, is that most DAOs in the beginning are probably going to start with some type of centrality. It's much easier to be fast when you don't have thousands of people to wait for a vote. And in the beginning, any protocol is going to be centralized to some degree anyways. Using a multi-sig where voting happens through only a few key members can be good in the beginning for your DAOs, and often emergencies as well. But just keep in mind, when you add one of these, you are adding this level of centrality. And then, of course, Open Zeppelin contracts. We love Open Zeppelin contracts. These are the contracts that we're going to be basing our DAO code along on. All right, so that's all the tools, that's the architecture. One more thing before I let you go. Legality. The future of DAOs is interesting for all these reasons we just talked about, but especially on a legal front. Does it make sense for a DAO to live by the same regulation as another company? How would you even force a DAO to do something? You'd have to force them to all vote a certain way if the government tells you to. It's a little gray. It's hard to nail down who to even keep accountable for these DAOs. In the United States, at least, you can actually form your own DAO and have it legally recognized in the state of Wyoming. This is something I want to do, so we'll just have to see what happens there. Woo! At this point, you have been injected with all the DAO knowledge you need to succeed and thrive with this new amazing technology and these new amazing concepts. And it's time to build, baby!